ask your permission for the recording of this lecture. Okay, thank you. Okay, so thank you for your response. So now we move forward with switching technologies. So switching technologies are we will cover the management of the switching technologies, network switch, its properties, and frame forwarding methods, operation of network switch, command line interface, configuration of switches using CLI, and advanced features of switch. So, what is a switch? So, a switch is a simplest plug and play device. So, if you want to connect to a server, so you try to use a switch if you have so many computers, and this would allow you to control all the computer that is connected to the switch. So you'll just going to put power to a switch and it's ready to transfer frame from one device to another. However, the advanced features on some switches enable administrator to fine-tune their networks for optimal operation. So switches work in data lake layer 2. So at this layer, physical address are defined, and the PDU at this layer is the frame. So instead of packet in router, so now our a unit of information here is a frame in the switches. So switches receive frames on one port and forward the frames out of the port where the destination device can be found. Switches flood broadcast frames out of all the ports. And when the switch receive a broadcast frame, so this is your destination address, and it forwards the incoming frame. And this method where a switch forwards a frame out of all the ports is called flooding the frame. So each switch port is considered a collision domain. So why? So in this example, I created this network. So when you're going to finish the simulation, what will happen is you will have some collision. Why collision? Because your switch cannot handle simultaneous transfer of frames. So you will see on this example later that there will be some fire on the computer, meaning there is a problem. And it's not really a problem, but it would take time for this to be resolved. So the switch doesn't forward collision information because its behavior limits the collision effects only to the devices connected to the port. So each port is called a collision domain. Switch ports can operate in full duplex mode, allowing connected devices that also support full duplex to transmit and receive simultaneously, thereby eliminating the possibility of collision. However, though collision can't occur on a port in full duplex mode, each port is still referred to as a collision domain. So this is an example of the simulation. So let's say if you're going to transfer one data to another, so you transfer here to here, and this data, for example, to here. So you will have I think this is a video. So let's simulate this. This is from the Pocket Tracer. So when you see this one, this is collision because there are two uh, uh, frames are being transferred. So, and at the same time, you cannot do this in a hub. You could do this only in a switch. So when there's collision, you cannot be able to transfer the data. You will see X. So when you see check, meaning the data is being transferred. So again, I will repeat the simulation. So collision. So once the green send here, so if it is successful, it would able to and then going here and here. So this is collision because this is a hub, and the second sending of the frame, it would be already good because there are no other connection that is being distributed to have only this point. So this one will be returned and you will have a successful transfer of information. So what is the difference between a hub and a switch? So a hub is unintelligible, and switch maintain physical address, stable, and intelligent device. It's always broadcast, so that's why you see if you send the data there in a hub, it will broadcast through all the connections. So a switch will only broadcast to a specific location. Now, if third, a hub works with zero and ones, and switch works with a physical address. Fourth, it's work with a shared bandwidth, and while switch works with a fixed bandwidth. And also we have hub contains one broadcast domain and one collision domain, while the switch have a default one broadcast domain, and number of collision depends on the number of ports. So that's the difference between the two. Now, what are the switching technologies that we have? So we have switch modes of operation. So most switches have the capability to work in multi modes. So, for example, it works on a switch for an instance, and it can usually operate in multiples of speeds and modes. So these are the modes that the switch can operate. And also the other features of switch now, we could have the auto negotiate mode, which means that the switch exchanges information with a device connected to a port and attempts to set the port's operating mode to the highest performance setting when the device supports. So if the device is set to operate at a particular speed, the duplex mode is a setting configured to the network interface card, and the switch sets the port to match the connected device settings. So another option you sometimes find in a new network switch is they have this auto MDIX. So this is a media dependent interface cross in which the switch detects the type of device and the cable it's connected to. So if it is you have a crossover or straight through cable, so auto MDIX can usually enable or disable this. So it would able to operate regardless of the type of the cable you are connecting to the port, and you can configure it separately. So this is an example of the switching table. It's composed primarily of physical address and the port pairs. So it tells the switch where to forward the frame based on the frame destination physical address. When when a switch is powered on, uh, at first the switching table is empty because the switch hasn't learned yet the devices that are connected to the port. So that's why it takes time for your switch to identify your physical address when it's turned off and on. So this is one example that we can have. So switching table prevents stale entries by including timestamp when a switching table entry is created. So as you compare, so you have this uh, port, is it switch 1, and we have a switch 0. So let's say 0, 0, 5, 0, 5, 6, 0, 0, 1. So this one, let's say this switch 0 is your port 1 port number, and this second 00563C21 is also connected on this side, and this one is connected also to your port 1. This is your port 1, and this is your port 5. So that's how you make a switching table based on the port. So what are frame forwarding methods? So we have the simplest and the fastest with the cut-through switching, in which the switch reads only enough of the incoming frame to determine the frame source and destination address. So one of the benefit of using this method is speed, and the disadvantage of this is it can forward frames containing errors. So it ties up bandwidth and needlessly frame that will be disregarded. So this is an example of cut-through switching. So the PC sends Ethernet frame, and as soon as the physical address is received, the switch make a lookup on the table. And when the switch finds this location, it's going to be sent to the computer. So if it is matched, so you could be able to receive the frame. So that's how cut-through switching works in a switch. So next one is we have store and forward switching. So this requires the switch to read the entire frame into buffers before forwarding it. So the switch examines the frame, checks sequence, and to make it sure that it contains no errors before forwarding. So if an error found, the switch disregard the frame, and this method has the advantage of conserving bandwidth when many frames contain errors. So one of the disadvantages is that the entire frame must be read and stored in the memory and examined before it can be forwarded. So it takes time and it slows down the network slightly. So it reads the frame once it's being read. So the switch stores the frame and calculates the error. If there is no error, the switch will forward the frame to the destination. So CRC is a cyclical redundancy check. This allows you to check the information if it has the match. So before forwarding, all of the necessary checks were being identified. Once there are no error, you can now forward the data to the computer. So that is store and forward switching frame method. So we have on the other hand, store and forward switching requires that a switch must read the entire frame to its buffers before forwarding it. So you have the third popular switching method. We have the fragment-free switching, in which the switch reads enough of the frame and guarantee that it's at the least minimum size for the network type. So one type of frame error that can occur in a network is a frame fragment, meaning the frame is damaged because of a collision or a malfunctioning device such as a network interface card or hub. When this type of damage occurs, the frame might be truncated to less than the minimum allowable size. A switch operating in fragment-free mode detects this problem and disregards the frame without forwarding. So this is an example of a fragment-free switching. So at first, the frame will be checked in as a free error, and once it was fragment-free, it would be sent to the switch, and the switch will forward this to the destination computer. So this is the content of the fragment-free frame. So this would be first established. So if it is having no error and no fragment, so it would be forwarded to the switch, and this frame will be used to transfer information. So what is a command line interface? So later, this is the command line where you type the code. So in Pocket Tracer, you have this example. And in my previous videos, if you want to check, so there will be some sample codes there that you will able to see the how to configure the switch. So you just going to type en enable, and after you will have config, And once you see config, you will configure the terminal, the memory, and the network. So you will just press enter. And if you want to exit the command line, you're just going to press Control Z. Now, if you wish to configure the first port, so you're just going to type the port. And if you want to exit, you need just to type exit. So this is an example of the switch command line interface. So starting the program, you need to enable. And if you want to configure, you have to type config. But another option that we usually do is using object-oriented window where we're just going to click CLI and not using this command line. So this is a command line interface. And for the advanced switch features, so we have this now later we'll go with the laboratory. So for the advanced switch features, so we have these smart switches and managed switches that can offer more features to help you design your own network. So we have multicast processing, you have spanning tree protocol, virtual local area network, and port security. So processing frame contains destination and on a special address that signifies one or more computers or devices. So when a computer is configured, the computer can be configured with all the applications that the classroom needs. So then an exact copy of the disk is made and stored on the server. So every computer uh, IP address is stored on the server, and the next image is transferred by using multicast frames only to the computers that require and at a running that makes it the term listening. So you can be able to receive the application by multicast frame by using the method listening because the image is sent only once and only the computers running the disk imaging program receive the frames. So this is an example of a multicast processing. So you could send one application and you could provide it to all the computer. So this by treating them as broadcast and flooding them to all the ports. So by forwarding the frames only to the ports that have registered to the multicast address. So if this registered and this one is registered for the multicast address, they will receive the information. So in this example, you have this computer and this computer have registered for the multicast processing. Now we have a spanning three protocol. So unlike hubs, so designed to accommodate redundancy and multiple paths. So in the network, however, redundant switches can also cause a network administrator worst nightmare. So we call it the switching loop. So this occurs when switches are connected in such a way that it's possible for the frames to be forwarded endlessly from switch to switch in the infinite loop. So every frame will be forwarded to every switch in the connection. So what is a virtual local area network? So this is our lecture 5. So it allows you to uh, physically connect to other computer without going to that computer. So you are, example, in the Philippines, if you want to connect to US, so you will use a VPN. So once you use VPN, so you going to automatically gain information from the other network outside from your country. And also this allows you not to be monitored by other computer because this is just connecting to another computer. And most of these are paid, so it's legal to use VPN. So how do you communicate these virtual networks and or routers or broadcast domain? How do you communicate? What do you use in virtual local network? What do you use in a virtual local area network? So you use, what is this? You use a switch and a, what symbol is this? In order for you to communicate to the network, you use a, you use a router, okay? So that's correct. And that's how you establish a virtual local area network. So also we have what we call the term is about virtual LAN. One switch to a port in each virtual LAN to another switch. So this enables you to connect to the server as well as to other broadcast domain users. So this is a switch or a router must be also configured as a trunk port. And this IEEE 802.1.1Q defines how to configure the trunk port. So how about port security? So that's why we use switch in order for us to control the network access in difficult and also it allows us to monitor public users and also unauthorized physical address at times to connect to switch the port, and it can be disabled. And also a message can be generated to indicate violation. So sometimes you will see that if you move to this site, you're not allowed by administrator to do this. So there's a control of the information that you're going to receive by controlling the port. So you could control what website that will be allowed to have access. So as a summary in our lecture, so we have all switches have the main objective that is to receive frames on one port and forward them to another port. And also the advanced features of switches can be categorized to multicast processing, spanning tree protocol, virtual local area network, and port security. The switch that enables you to create multiple broadcast domain can offer many benefits for your network. A switch with virtual LAN capability can optimize your network configuration by creating broadcast domains without having to add switches. And also, port security on most switches enables administrator to limit how many and which physical address can connect to the port. So these are the summary. So comparing the switching method, so we have the cut through, which is the fastest. And one of the disadvantages that it could forward errors. We have fragment free. The switching performance is average. All errors except frame fragments are forwarded. And we have also one of the useful, but one of the slowest. We have store and forward, which no error frames are forwarded because it would be checked by the process. So that's it for this lecture. Any questions? So if there are no questions, we are going to finish the recording and